Good afternoon. My name is Lisa Garcia-Loya, Vice Provost for Graduate Studies and Dean of the Graduate Division here at Berkeley. It is my sincere pleasure this afternoon to welcome you to the 2021 Berkeley Grad Slam competition. Today's event comes on the heels of Graduate and Professional Student Appreciation Week, a week that seeks to emphasize the contributions, impact, and value of graduate and professional students on campuses throughout the United States. What could be more fitting than to follow up that week with Grad Slam, an opportunity to celebrate and make visible the outstanding research done by Berkeley's graduate students. Grad Slam was launched 7 years ago by former University of California President Janet Napolitano, with the goal of sharpening graduate student communication skills and providing an opportunity for the public to learn more about the research being undertaken by graduate students at the 10 UC campuses. This program also enables us to demonstrate our commitment to access and inclusion in that it asks graduate students to present their research in jargon-free language. Especially as a public university, it is our responsibility to communicate our research in a manner that is accessible to a general audience and not just to academic specialists. Here's how the UC-wide Grad Slam competition works. Each of the 10 UC campuses conducts its own campus-wide competition and selects a finalist to compete in the system-wide event, which will be hosted this year by UC President Michael Drake on May 7th. That competition will also be held virtually, and we hope you will all join us again then to cheer on the 10 UC finalists. Here is the process we use at Berkeley to determine who our campus finalist will be. A faculty subcommittee of the Graduate Council reviewed videos submitted by graduate students from a range of disciplines and selected the 7 semi-finalists whose presentations you will hear today. Let me take this opportunity to thank the members of the Advisory Committee for Graduate Student and Postdoctoral Scholar Professional Development for their hard work to make today possible. We know there were many worthy submissions. Today's finalist presentations have been evaluated by a distinguished panel of judges. I would like to take a moment to thank each of them for their service. They include Nancy Freitas, the 2019 Berkeley Campus Grad Slam champion and a doctoral student in the Energy and Resources group. Wendy Tokuda, award-winning American television journalist, speech coach, media consultant, author, speaker, and naturalist. And Eric Stern, Senior Vice President, Capital International Investors, and also who serves as the chair of the Graduate Division's Executive Advisory Committee. Our sincere thanks to each of you for volunteering your time and making today's event possible. In addition to the panel of judges, several years ago, we introduced a new feature to the competition. You, our audience members, will also be judges today. After hearing all the presentations, you will be invited to vote to select a People's Choice winner in today's event. More about that later. Now I am very pleased to introduce and welcome Nancy Freitas, the 2019 Campus Grad Slam champion. Nancy is a doctoral student in the Energy and Resources group and has kindly joined us here today to share her reflections on the value of the Grad Slam program. Nancy.
Thank you, Lisa. I'm very excited to be here today and would like to start by saying how impressed I am that all of these participants have dedicated their time to this event, both in light of the intense difficulties of the past year and in spite of the very real thing that is Zoom fatigue, because I recognize that you're here online yet again. So thank you for sharing your work with us today. 2 years ago, I walked into an auditorium on campus to participate in Grad Slam, and I had no idea what I was getting myself into or what it could mean for the future of my work. What I did know was that I was super nervous and was like questioning every decision I had made to stand in front of some 300 people to talk about my work. But the reason that many of us are in grad school is because we want to affect positive change in our societies. And what I had found when I came back to academia was that we weren't teaching researchers how to communicate clearly outside of publishing papers or writing blog posts. we weren't being taught how to develop research projects alongside communities and how to extend the tools and the process of science beyond academia. And it felt frustrating because so many of the issues that we talk about on a daily basis require more than just pure research to take action towards. They're nuanced, and they might be sociopolitical or economic, and they deal with issues that inherently exist beyond the walls of our institutions. So all that's to say that I found myself in an auditorium trying to learn how to take this step and surrounded by other people who were doing the same thing. And something that stuck with me about Grad Slam was how amazing it was that one person could stand up and talk about climate change, and the next could get up and talk about music or public health. Because it made me realize that I was part of this larger community that really did want to share the excitement of our work. And Grad Slam moved me beyond the lens of my own research and quite honestly ended up changing the trajectory of my PhD. And this is because it pushed me to think about the relevance of my work more deeply and to think about who I was involving in it. And I also started thinking more about how I could be collaborative and interdisciplinary as a scientist and also more generally as a member of society. So when we think about the value of discussing our work and the benefit of opportunities like this, I think it's in their ability to both change mindsets and provide models for engagement. Because right now, our planet has been rocked by a pandemic. Our nation is grappling with both a present and a history of entrenched racism, and also a responsibility for major climate changes. And I think that this introduces a new social contract for us as scientists and as researchers. These problems are so complex that they require us to step beyond the silos that research has traditionally existed in, because we have to connect across divides in order to tackle these issues. We need to expand access to research spaces to a greater diversity of people by removing barriers like tuition hikes, article paywalls, and inaccessible jargon. And it looks like working with communities and policymakers and researchers from other fields to define the problems and the questions that we ask together. So I think that each of us needs to examine how we walk through the world as academics and to begin to build bridges with one another. And Grad Slam is actually one of the many steps that makes that possible. And to me, talking about complex ideas in complicated ways is actually quite easy, but it's taking those ideas and distilling them down to their elemental parts, and then talking about them with different audiences that is much, much more difficult. But it's also where these conversations begin to affect change and to bring people into the dialogue. So in hindsight, even though 2 years ago I was super nervous about participating in Grad Slam, I would do it all over again in a heartbeat, because opportunities like this are critical for expanding our ideas of what research can be and for teaching us how to create this common thread of understanding with stories about our work. So I'm thrilled that the participants are taking the step today to sharpen their communication skills and that they're here to share their work with us. So best of luck to you all, and thank you also to our audience members for being here.
Thank you so much, Nancy, for your powerful words and for reminding us of how important it is to be able to tell our stories in ways that bring other people into our work. Thank you so much. In a moment, we will begin the presentations. First, I wanted to give you a word about the order of the speakers, rather than the usual last name alphabetical order, with the goal of greater fairness and kindness for those people whose names start with Z. We have randomized the selection for the order of presentation. For the Grad Slam competition, each contestant has 3 minutes to present their research. According to the guidelines used in all Grad Slam competitions, presentations are judged based on their intellectual significance, appropriateness, clarity, organization, engagement, delivery, and visuals. Points are deducted for every 3 seconds that exceed the 3-minute time limit. Taking this year's system-wide Grad Slam's virtual format as our model, we had each contestant pre-record their presentation. Our contestants are also here with us live. So after each presentation, I will be asking each student a few informal questions so we can get to know them and hear about how they came to their research area and what their future plans might be. After all 7 presentations are complete, you will be invited to select the People's Choice Award recipient through an online link that we will provide at that time. At that time, we also will invite the audience to submit questions for our panelists. After our contestants have answered the audience questions, I will then announce the winners. All 7 competitors today will receive at least $300 in recognition for being the finalists in our competition, with the People's Choice second and first place award winners receiving $750, $1,000, and $3,000 respectively. Today's first place winner will go on to represent Berkeley at the UC-wide competition next month on May 7th. Again, after the presentations are complete, the audience will have the opportunity to ask questions and vote for the People's Choice winner, and we will provide the links at that time. And on to the presentations, what you've been waiting for. Our first presentation is from Bren Cease, a 6th-year doctoral student in astrophysics. Let's play the video.
What do you see when you look out into the night sky? Stars, like our own sun, living in galaxies like our own Milky Way. For over a century, astronomers have looked out into the night sky and studied the many different galaxies we see there. And we found that galaxies broadly separate into 2 distinct groups. One group is galaxies like our Milky Way that are actively forming new stars. The other group is what we call quiescent galaxies that aren't forming any new stars. But quiescent galaxies have tons of old stars inside of them. So we know that at some point, these quiescent galaxies had to have formed all of these stars and then stopped making new ones. But despite how long we've known about this galaxy by modality, we don't understand why it happens. What makes galaxies stop forming stars? During my PhD, I've been trying to answer this question by studying a sample of galaxies that we think just underwent this transition. This is the perfect sample to study the physics of what stops star formation, because the signatures of that process should still be there if we look in the right places. In this case, the right places means looking at what happened to the fuel for star formation. The idea here is that maybe galaxies stop forming stars because they ran out of the fuel to do so. In a way, it's the simplest possible explanation. It's like how your campfire will burn out if you don't add any more wood to it. The fuel in this case isn't firewood, though. It's cold molecular gas. That's what galaxies use to make new stars. So I'm measuring the amount of cold molecular gas left in a sample of galaxies that just stopped forming stars. I'm using ALMA, a giant array of radio telescopes that lives at 16,000 feet in the desert in Chile. And my collaborators and I were fortunate enough to be able to point this amazing billion-dollar instrument at a dozen galaxies in our sample. And what we found was really surprising. Again, these galaxies aren't forming any stars, so we didn't expect them to have any cold molecular gas. No fire, so no fuel either. However, we found that about half of the galaxies we looked at had these booming molecular gas detections, way more gas than we can explain given the fact that they're not forming any stars. So we were wrong, halfway at least. But these surprising and mysterious gas detections challenge our views of galaxy formation. So we're currently trying to figure out what could explain our observations. Maybe some of these galaxies recently collided and merged with other galaxies, or maybe the supermassive black holes at their centers are in the process of tossing all of this gas outside of the galaxy. We don't know. So we're currently collecting more data to understand this puzzle of galaxies with tons of fuel, but no fire.
Thank you very much, Ren. Thank you for the wonderful presentation. I'd like to take the opportunity to ask you a few questions so that the audience might get to know you a little better and know a little bit more about your work. The first, and I guess I'll warn all the presenters, I'm going to ask all of you this because I think it's a really important question. What made you decide to go to graduate school?
Yeah, thanks, Lisa. That's a good question. I think that, so I did an undergrad degree in physics in Boulder. And when I was there, I took a class on cosmology and relativity and started doing research with the professor that taught that class. And it was just so fun. I was looking at real data and I was coding and I was talking to other people about science. And I was answering these big questions about, how we got to be here and why the universe looks the way it did. And so for me, the idea of doing 6 more years of that sounded really fun. So, yeah.
And so what made you decide on this particular area within that broad field to focus on?
So I think that the thing that I really love about studying galaxies is that it combines really small scales and really large scales, because we have to think about things that are happening on the smallest physical scales. So, the quantum mechanics of how different molecules are emitting light at different frequencies, as well as these processes that are happening on, the largest scales as gas is collapsing into forming galaxies. And then the same with timescales, where we have to think about things that are happening on, nanoseconds or less, as well as things that are happening over billions of years. So it's a really complicated multi-scalar problem that, there's a lot of interesting questions left to ask.
Speaking of the questions you get to ask and the work you get to do, what's the part of your work that's the most fun for you?
Well, I love observing. So the data that I was showing here is from ALMA, which basically they take the data for you and then you just wake up one morning and it's in your inbox. But one of the really fun things about being an astronomer is getting to actually use telescopes. And so as a member of the UC, we have access to the Keck telescopes, which are on Mauna Kea in Hawaii. And so I've had the opportunity as a grad student a few times to go out there. And there's somebody who's actually doing the pointing of the telescope because it's very complicated and expensive and they don't want me to break it. But I get to operate the instrument and basically stay up all night. You start at an hour before the sun goes down and you stay up until the sun goes up taking data.
Well, my next question was going to be the hardest part. I'm guessing lack of sleep might be one. Are there other things that have been challenging for you?
Well, I will say on the lack of sleep, I didn't drink coffee until I was a grad student, and now I'm fully addicted. I'm sure I'm not the only one in this room that would say the same thing. I think in general, grad school is hard because you have these really big questions that you're trying to answer, and there's not a lot of metrics for success other than papers, which are pretty long timescales. So you have to learn how to manage your own time and find ways to feel like you're actually making progress, which is a big transition.
Yeah, absolutely, Ren. The independence is really hard sometimes, right? It's the best and the worst, absolutely. Well, thank you so much, Ren. I do think it's important to acknowledge the Mauna Kea telescope is a little bit controversial for some folks, but just to say we're happy that you've enjoyed your ability to work at that site. But yeah, just feel like I need to say that for people in the audience just to acknowledge. But thank you so much.
Yeah, no, thank you for bringing that up, Lisa, as well.
And our next presentation is from Rachel Woods Robinson, who is a 5th-year doctoral student in applied science and technology. Let's play the video.
Solar cells are crucial to combat climate change, but their efficiencies still lag behind theoretical limits. Why? Imagine you shrunk to the size of a single hair and crawled into a solar panel. You'd see layers of materials stacked up together like a sandwich. In silicon solar cells, silicon is the absorber layer. It takes in sunlight and converts it to electricity. Absorbers get all the hype, but a bigger research challenge is actually in the contact layers. Even with a perfect absorber, electricity still has to flow out through the contacts to get to the circuit, or it will be lost as heat. Bad contacts are a key reason why solar hasn't reached theoretical efficiency. So, can we find better contact layers to enable climate change busting solar cells? Okay, wait, there's a catch. To make electrical contact while still letting light into the solar cell, we need a special material that's both transparent to sunlight and conductive to electricity. But these two properties typically work against each other in nature. Metals are conductive but not transparent, and glass is transparent but not conductive. And there's a second catch. We really need contacts that conduct a particle called a hole, the positive counterpart to the negative electron. Kind of like bubbles in a sea of water, holes are the empty spaces in a sea of electrons, and like bubbles, holes can move through materials, so we need a transparent contact that can move holes. But physics makes transparent hole conductors way trickier than electron conductors, and so far there are zero good enough for solar. My hypothesis is that materials do exist with these properties, transparency and hole conduction. We just haven't looked in the right places with the right perspective yet. In my PhD, I get to be a materials detective and use the magnifying glass of research to scour the hidden corners of the periodic table for a promising transparent hole conductor. Here's my three-step approach. First, I turn to Berkeley Lab's Materials Project, a Google-like database of all known crystalline compounds across the periodic table. I devise a series of search criteria each compound must meet, and then with my trusty sidekick, a supercomputer, I run calculations to filter the database down to a small subset of promising candidates. Second, I'm off to the lab to grow these candidates as thin films and use custom measurement tools to assess whether they're actually transparent and hole conducting in real life. And third, I incorporate the most promising materials as contact layers in solar cell devices to test them, and then I apply what I've learned to start the cycle again. With my combined theoretical and experimental methods, I've made dozens of predictions, I've synthesized new compounds such as metal-sulfur chemistries, and I've measured some high hole conductivities and transparencies. These exciting results also offer intriguing glimpses into physics that's been previously overlooked, which I'm now investigating as a way to enable even better transparent contacts and ultimately to maximize solar efficiency. Now, zoom back out of the solar cell and imagine these clever contacts on rooftops and on fields around the world. Let's work together to make this a reality so clean electricity can flow out of solar cells and society can flow away from the climate crisis.
Thank you, Rachel, for that excellent presentation. Now I'm going to take the opportunity to ask you a few questions, as I did with Ren, so that the audience can get to know you a little bit better. And we'll start with the big question, which is what made you decide to go to graduate school?
Thank you. So I came to grad school because I wanted to work on technology to combat climate change, specifically on the underlying science challenges of solar energy and just like learn how sunlight interacts with stuff. But to be honest, I didn't actually want to go to grad school for a while. I didn't even want to be a scientist for a while. As a kid, I wanted to be a musician, a jazz trombonist to be specific. And this was because when I was a kid, we would have musicians come through to our school and teach lessons and present to us. And I didn't really have that with science. I actually never met a practicing research scientist until college, and I had no idea it was something you could be. So, and then when I finally got interested in science, I dreaded going to grad school because I didn't want to zoom in on like a tiny topic and get stuck there. So I ended up coming because I found out there were actually ways you could do interdisciplinary work, like the work that I do, and work to communicate science with others. So that's been really amazing.
Well, we're grateful that we ended up taking you from music. But what particularly got you interested in climate change as a topic?
Well, I guess I don't really work on climate change. I work more on like a specific technology for climate change.
All
but
right.
the reason of like I'm interested in climate change is because it's one of the greatest threats to our society, and there are things that we can do as scientists to really transform to a renewable economy. And so I care really deeply about addressing climate change. And since our planet is near a giant orb of practically infinite renewable energy, well, I guess it's not as infinite as what Ren was talking about, but it's kind of a no-brainer to use its rays to power electricity. But solar is still only, this blew my mind, I didn't actually realize this until recently, solar is still only about less than 1% of our global energy generation. So we have a lot of work to do. And also I just think crystals are really cool, and solar cells are made of crystals. So when I found out about that, I was sold.
So speaking of the aspects of your work that are cool, what do you think is the most fun or sort of interesting part of your work you want people to know about?
So I really love how collaborative my work has been during my PhD. So I love working in teams, and I've been able to travel to the National Renewable Energy Lab, as well as I do a lot of my work at the Berkeley lab. And I went to go to Switzerland to fabricate solar cells. So being able to, I really like being able to both simulate crystals on the tiny atomic scale, all the way up to making real solar cells in a lab that I can hold in my hand, and I can draw from like all these different fields. And so it's really challenging, but really exciting.
Thank you so much, Rachel. Our third presentation is from Adelaide Bernard, a sixth-year doctoral student in metabolic biology. Let's play the video.
Have you ever wondered how your brain decides how hungry you should be? Well, it all depends on your energy status. Your fat stores are like a battery, and when the battery is overcharged, it talks to your brain, so it can respond by decreasing your hunger. This system relies on a receptor called MC4R. MC4R is a master regulator of hunger. Its activation makes you feel full. Unfortunately, in some individuals, this system doesn't work. Mutations in the gene necessary to make MC4R are the most common cause of monogenic obesity. And patients with defective MC4R feel hungry all the time. In the US, 2 out of 3 people are overweight or obese. My goal is to understand how MC4R senses and relay information about our energy status to hopefully be able to activate this circuit in patients that struggle with their weight. Out of the billion neurons in your brain, only a few produce MC4R. These MC4R neurons receive information about your energy status from primary fat-sensing neurons to then decide how much you should eat. Textbooks will only tell you that neurons communicate through synapses. This communication is extremely fast, and it works like this. If I were a neuron, I would get information in form of chemicals through a synapse, transform it to electricity to then pass the message to the next neuron in the same way. But we discovered that this isn't how MC4R works. MC4R can't get information in this way because it's not physically located at the synapse. Instead, MC4R works in a very specific part of the cell called the primary cilium. This cilium is like an antenna because it senses signals from the extracellular environment. Although most of our cells have a primary cilium, how cilia function in neurons is not well understood. But we do know that when this antenna doesn't work properly, it leads to obesity. My hypothesis is that because MC4R needs to be at the cilium to control hunger, the loss of any molecule that brings MC4R to its antenna would break the system and lead to obesity. And I discovered that a protein called MRAP2 is MC4R's shuttle to the antenna. Using genetic tools, I deleted MRAP2 from neurons in mice, and I saw that MC4R couldn't enter the antenna anymore. These mice were hungry all the time, and they became obese, demonstrating that MRAP2 shuttling MC4R to the antenna is absolutely necessary to dampen hunger. My findings give a new perspective on how neurons exchange information and how neuronal primary cilia regulate energy balance. This discovery is super exciting because understanding how this antenna works and how it's impacted by our diet and environment will help us understand why it is so hard to lose weight and maybe develop new therapeutics to fight obesity.
Thank you, Adelaide, for that wonderful presentation. Now I get to ask you a few questions so that the audience has the opportunity to get to know you a little bit better. First, what made you decide to go to graduate school?
Hi, Lisa. Thank you very much. I've always loved teaching and explaining things to my classmates. So I thought, when I was a child, I would become a teacher. And then as a teenager, I realized that most, when a teacher gives his class, at least 50% of the people are not really paying attention or not interested. So I realized that if I wanted to have a full class interested, I might need to become a university professor. And so then I learned that I would need to do a PhD if I wanted to become that. Then I learned about all the other implications of doing a PhD, and I still loved it. So here I am today.
That's great. What made you interested in this particular area of research as you were thinking about becoming a professor?
Yeah, so I landed in the lab where I am now a little bit by chance during my internship for my master's, because I first did a master's back in Belgium, and I just loved it. I already knew that I loved neuroscience, and as a teenager, I struggled with my weight a lot. I did so many diets and they didn't really work out. So when I landed in the lab where I am right now, being able to do research that is the mix between neuroscience and metabolism and understand how all those things work really, where it was so magical for me to understand a little bit better and feel like I could, my research could help also understanding how that works.
It's so nice to hear research framed as magical. Usually we don't use those words, but it is when things come together. I think for all of us, it's really special. Thinking about when those things come together, what are the aspects of your work that you think are the most fun or the most interesting that you want people to know about?
Yeah, of course, teaching, right? Because that's what got me into it first. And then I'm into photography, and for my work, I do a lot of microscopy. So that was definitely one of the things that I really love to do. All the parts that are microsurgeries in the brain are also super interesting. And also the fact that, this is a topic that I can discuss with people, my friends in general, because you really make it approachable for people. I hope you can hear that because my connection is not stable right now for some reason, but.
Yes, thankfully we could hear you. You it jiggles a little bit, but you were okay. I'm sure I probably share the feeling with many of your audience that microsurgery in the brain does kind of make you go ew a little bit, or just worrisome for those of us that think about those things. But to talk about not just the good part, what are the most challenging parts of your work so far, or being a graduate student in general?
Yeah, I feel like accepting that you're not going to be able to answer all the questions that you have is a big part of it. The first time I set up my project and I went to a core to try to understand what kind of experiments I would need to do. And they told me, that's like a 5 years project, and I only had 6 months. That was for my internship. And I was so sad not to be able to go through the end of it. So yeah, I think that's one of the most problematic parts.
Well, thank you, Adelaide. For what it's worth, my students have the same challenges. It's important to remember that your academic life is a whole lifetime. And so you'll have plenty of time to do all of those projects if that's the track that you're on, or that's where you want to spend your professional life. Thank you so much, Adelaide. So our fourth presentation is from Iman Rana, a first-year doctoral student in environmental health sciences. Let's play the video.
Imagine finally buying your dream home. You're probably thinking hardwood flooring, luxe furniture, maybe even a walk-in closet. Okay, let's be real. We want a huge walk-in closet. The thing that I think of is that new home smell. That familiar smell is a chemical called formaldehyde, typically emitted by household products from cabinets to flooring to furniture. The bad news is that formaldehyde is an extremely reactive chemical. When inhaled through the nose, it can collide with a delicate neurological structure called the olfactory bulb. Early studies in lab rats linked formaldehyde exposure to memory loss, so I decided to take it a step further. I wanted to know whether formaldehyde exposure is linked to neurodegenerative disease or brain cancer, and if it is, what's the mechanism? To answer my question, I reviewed over 2,000 studies and was disappointed that I didn't have a clear answer. I then used a statistical tool called meta-analysis to combine data from many different studies. The results were shocking. I found that high formaldehyde exposure resulted in a 78% increased risk of neurodegenerative disease called ALS and a 71% increased risk of brain cancer. Even though I detected a statistical association, I needed to truly understand whether our findings were biologically believable. How is this happening? My team then turned to a next-generation bioinformatics approach to try and tease out specific mechanisms. We generated an integrated network that overlapped all the genes and pathways highly associated with formaldehyde, ALS, and brain cancer. We were surprised to find that the folate and vitamin B12 pathways were both linked to the endogenous formaldehyde cycle and were diseases of interest, indicating that deficiencies in these pathways could make a person more susceptible to formaldehyde exposure. The pathway most affected by the air pollutant was the ALS pathway, confirming the results in our meta-analysis. The final piece of the puzzle was using these data to assemble a mechanism that explains just how formaldehyde can lead to these very different diseases. My team is the first to uncover a biologically plausible and statistically robust association between high exposures to formaldehyde and ALS and brain cancer. So what does this mean for your dream home? Hopefully that it has more closet space and less of that smell. My research is turning the page and helping us to protect people from brain disorders, create health-based policies, and ultimately create a safer environment for generations to come.
Thank you so much, Iman, for that excellent presentation. And now I get the chance to get to know you a little bit better, and I'll start with the same question. What is it that attracted you to graduate school?
So I attended undergrad at Berkeley, and I think I was just left with more questions than answered. So I was, I did my undergrad, I did my master's, and I couldn't say goodbye. So here I am staying here to tie up loose ends and really try and figure out how these chemicals in our environment can lead to different types of diseases.
Thank you. And go Bears. As a former Berkeley undergrad, I appreciate not leaving this campus since I'm still here. So what is it though about this particular question was most interesting to you? There are a lot of different kind of concerns about the intersection between human behavior and chemicals in the environment. So just curious why this particular area was so interesting to you.
Absolutely. So I grew up in an immigrant community in Chicago, and I was really surprised to learn that a lot of the chemicals that folks in my community were exposed to are actually the same types of chemicals that we are researching right now. So understanding the direct implications of how these chemicals can interface with our body and potentiate different types of diseases was really personal to me. And it's put a lot of meaning behind the hard work and effort that's gone into a lot of these projects.
Thank you. Thank you. I appreciate how deeply personal this kind of work can be. In addition to that sort of appreciation of the ways it maps onto different kinds of inequities, what are some of the other sort of challenging aspects of the work that you're doing?
I think probably the most challenging element has been deciding where to stop. I think every step of the way we come across new data, new information that leads us to ask more questions. And I think that just deciding, okay, this is the scope of this project, and that's sort of a problem for another day, is hard because of how exciting and how important it is to me.
Are there any aspects of the work that are fun for you or that you think people would want to know about?
Yeah, absolutely. I think probably the coolest thing about my research is the fact that this is not something that occurs, in some corner of the world to people that we don't really have a face of or some type of picture of. These are chemicals that all of us are exposed to. And I think every single person in this room and watching on YouTube and beyond is exposed to formaldehyde. And that's why this is important. This is something that we all, we really need to understand because we're all being affected by it. It's affecting us, people we love, and people in our communities.
Thank you so much, Iman, for the important work that you're doing and for reminding us of how these sort of chemicals we engage with every day, really thinking deeply about the impact they're having on our bodies and our communities and how those things are not distributed necessarily equally across different kinds of communities. So thank you.
Thank you for having me.
Our fifth presentation is from AJ White. He is a fourth-year doctoral student in anthropology. Let's play the video.
Do you ever wonder what happens to your poop after you flush it down the toilet? It goes away forever, right? Well, not entirely. Although most of it will quickly degrade, certain molecules in your poop called fecal stanols can persist for hundreds to thousands of years. Turds are fleeting, but your fecal stanols are forever. Or, at least a couple hundred years. Fecal stanols are useful to archaeologists like me for three main reasons. One is that humans are the dominant producer of these molecules, so in most cases, we can use them as human biomarkers. Two, we can use changes in their concentration through time to build a population reconstruction for an area. And three, fecal stanols tell us about population changes that happened in parts of the world where we simply don't have demographic records. In essence, we can make history from poop. Now, you got to think of a time before toilets, when most people defecated outdoors. After it rained, some of that fecal material would wash away and collect in a low point on the land, something like a lake. With time, more or less of these molecules would get deposited, depending on the number of people who lived around the lake. So we can use changes in the concentration of fecal stanols through lake sediment with depth to make a population reconstruction for an area. I did that at a lake just outside of Cahokia, the largest archaeological site in America. Cahokia is located in southern Illinois, and it's essentially an ancient city. We know a ton about it from the time period of 1000 to 1400 AD, when it was occupied by the so-called mound builders, who established dozens of these monumental earthen mounds throughout the site. However, the story of Cahokia often just ends at 1400, when the area is said to have been abandoned and collapsed. The problem with this is that it brings a sense of finality, so it would be really easy to think that that was the end of indigenous people in that area. However, our fecal stanol record of the region paints a very different picture. We find that by 1500, fecal stanols start to increase, suggesting a population rebound that continues into the 1600s. This tells me two things. One, that the abandonment of Cahokia was relatively short-lived, perhaps no more than 100 years. And two, there was a later indigenous occupation of this area before the arrival of Europeans that has been largely overlooked by archaeologists. Although traditional oral histories tell a similar story, the fecal stanol record supplements this knowledge by providing quantitative evidence for an entire time period that was missed by traditional archaeology. The recognition of a later indigenous occupation of the Cahokia area helps us to emphasize Native American persistence instead of Native American disappearance. Thank you.
Thank you so much, AJ. Your presentation actually brought to mind for all the parents in the audience, the book that we give to all of our kids when you're potty training called Everybody Poops. And I've never fully put that in the context of then that helps us know who lived where. So thank you so much. I'll start with the same question I've asked other folks so we can start to get to know you a little bit. What made you decide to go to graduate school?
Yeah, thanks, Lisa. So I, in undergrad, studied geology and anthropology. And after I graduated, got a job as an archaeologist for a company going out and doing surveys in the desert. And I was using my knowledge mostly just to answer like, hey, man, what rock is this? Which didn't feel like a really, in a high order sort of use of my education. So I wanted to continue that to ask bigger questions. I was working in, the desert parts of California, which feel kind of inhospitable to me. And yet we're finding these archaeological sites of people flourishing in these environments that feel hostile. So I was really interested in going to learn more about the relationship between environments and people in the past. And fortunately, Berkeley's been a great place to do that.
Thank you. So what, it sounds like you've been interested in archaeology sort of broadly for a while. What is it that really brought you to that area of interest?
Well, yeah, to archaeology on the whole, I mean, it's fun. You get to travel, you get to be outside, and everybody likes to know about where they came from. And archaeology kind of helps you make that happen, to different communities throughout the world. And in relation to, the fecal study aspect of it, I think we all can relate to that, and I've been relating to it for about 30 years now. So, yeah.
So you talk about how being out is fun. For some of us, going on a site means, bugs and heat and dirt and other kinds of things. So how could you paint a picture for us about what's fun about doing field work in this area?
Okay. At Cahokia, where we got these sediment cores, yeah, I mean, it was kind of hard work. We were out on the lake for a very long time. The sun set and our motor broke on the boat. So we ended up having to hold a boat above our heads as we traveled through a swamp in Southern Illinois. There's a shoe somewhere at the bottom of the lake. That was my shoe that came off in that mud. So yeah, it's hard work, but it's also really rewarding to be doing the stuff that, most folks look at an archaeological site, more just as a wow, as a tourist walking by, but you get to actually kind of make that history and be a part of it. And that's the most fun and the most rewarding part to me.
So if there were one thing you want people to know about your work, what would it be? Or something that people might not think about in the area that you're working in?
Just in regard to the US, I think it's often kind of thought of as this really new country, and especially out west, we have this concept. But I just want to emphasize that there's a very long history to the United States, and an indigenous history that doesn't just end and a new one starts, it's continuous. And I think that hopefully this research helps to show that.
Thank you so much, AJ, for the opportunity to learn more about the work that you're doing. Our sixth presentation is from Netta Gottlieb, who is a final year doctoral student in psychology. Let's play the video.
Did you know that about 30% of all pregnancies result in a miscarriage? Statistically speaking, this means that every family with 3 kids has experienced a miscarriage along the way. Sometimes this happens even before the pregnancy is confirmed. And in most of these cases, we don't even know why. When we look at the reproductive checklist, estradiol and progesterone for women, testosterone for men, nothing seems to be wrong. But we still find a surprisingly high number of healthy couples under 30 who are having trouble conceiving. One research path that can help us understand why reproductive attempts might fail is the study of stress. Scientists have long suspected that chronic, ongoing stress leads to adverse pregnancy outcomes. In fact, we know very little about how stress affects reproduction, especially in the female reproductive system. This is where I come in. My goal is to understand how stress affects pregnancy. I want to fill in the missing pieces in this puzzle. Now, since pregnant women already experience enough stress, I used a mouse model to study how stress affects embryo development. Every day for the first half of their pregnancy, I put a little bit of fox urine in their cage. This predator odor provokes a life-threatening stress response. I then looked at different genes expressed in their brains, at pregnancy-related hormones, and I evaluated the structure and the function of their placenta, the temporary organ connecting a mother with her baby. Most remarkably, I have found that the placentae of stressed mothers look and function differently than those of non-stressed mothers. Their shape is abnormal. They're smaller and thinner, and there are holes in the tissue. Cells are literally dying. In those mothers with abnormal placentae, I also saw developmental delay in the embryos. In my future work, I will be exploring safe and effective ways to mitigate the negative impact of stress on pregnancy. Ultimately, I hope my work will identify targets for clinical treatments that will help conceive future generations. Until then, perhaps a doctor's advice should be to take your prenatal vitamins and throw in a relaxing walk on the beach. Thank you.
Thank you so much, Netta. And I'm so glad to hear that your research is now going to look at the prevention part, because as a working mother, when your doctor says you should reduce your stress, but you can't really change your life, it'd be good to know how to keep those physical effects from happening. So thank you so much for your presentation. I'll start the same way with you. If you could let folks know what is it that drew you to graduate school?
Yeah, thank you so much. It's such an honor to be able to share my work with all of you. I studied for my bachelor's degree in Israel, where I'm from, and I studied psychology because I thought it was very interesting, and business management because I thought it was practical. And the more I studied psychology, I learned about the biological basis of psychology, which I found fascinating and led me to continue to my master's degree in biological psychology, where I studied how stress affects immune function. And the more I studied about these physiological changes related to stress, I kept thinking about fertility and pregnancy. This is a topic that has always been on my mind because I come from a unique family with 5 siblings. Out of them, 4 are twins. So growing up as a twin with another brother and sister who are also twins, and for some part of my life, sibling and twin was interchangeable word for me. And it was a big aha moment discovering that it's not the case for everyone. But these fertility and pregnancy topics were always on my mind. So connecting these to stress was very interesting to me, which made me decide to come to Berkeley to work with Lance Krigsfeld and study the neural mechanism, the hormonal mechanisms underlying pregnancy success and pregnancy outcomes.
Thank you. I'm imagining your mom, assuming they're biological twins from one parent, that she was under a bit of stress if she had twins and then was pregnant with twins. So I can see, if that's the case in your family, why that would have been
exactly the case.
A stressful thing. What is the most fun about the work you do?
Oh, there's so many fun aspects. My amazing collaborators and research assistants and interacting with these brilliant people. And it really is a group effort, which makes everything more fun. So bouncing ideas off of each other's, discussing, the experimental design, and then thinking through the results and what it could mean in the big picture. and what are the ramifications and implications. This is, the group effort is absolutely amazing and fun.
And if there's one thing you want people to know about your area of study, what would it be?
I do want to reassure people that it's a little bit more complex than, this 3-minute version of the study, and there are protective mechanisms in place. So I do want to say that it's not worth stressing out about being stressed. So we can only do, what we can do. And I do want to reassure people that, there are protective mechanisms in place as well.
Thank you so much,
Thank
Netta.
you.
Our 7th and final presentation is from Michelle Phillips, who is another final year doctoral student in sociology. Let's play the video.
Migrant labor remains a political hot topic, but I study a kind you may never have heard of, the maid trade. To put yourself in these migrant shoes, I want you to imagine moving to a country you have never visited before, which primarily speaks a language you do not know, with no money, no bank account, no phone, no computer or access to internet, no friends, leaving your family behind knowing you will not see any of them again for at least 2 years, preparing to live in the home of your boss that entire time at their beck and call 24/7. This may sound unbearable, but it is the reality of life for 11.5 million people, primarily women, who have left their homes to serve as domestic workers in another country, often the only means available to support their families. This market sometimes borders on human trafficking and often leaves these women vulnerable to extensive abuse, debt traps, overworking, even sexual assault. But it's a legal immigration status in many countries. This is where my research comes in. As a sociologist, I tackle the problem of systemic abuse, meaning how and why social systems create and perpetuate abusive conditions. I study 2 of the most popular sending countries, the Philippines and Indonesia, and 2 of the most well-regarded receiving societies, Taiwan and Hong Kong. Using Mandarin and Indonesian, I conducted participant observation in these 4 countries for 15 months, visiting homes and shelters, and accompanying domestics on outings, court cases, even medical emergencies. Aside from also studying laws, websites, and news, I also conducted 245 in-depth interviews with not just domestic workers, but also government officials, employment agencies, activists, and even employers themselves. I found that what was supposed to be a well-integrated market connecting worker to employer, in fact, facilitates exploitation and corruption. Instead of taking charge of their citizens' well-being themselves, the 4 governments involved chose to delegate their responsibilities to the private industry. This arrangement gave private agencies an inordinate amount of power over the domestic workers. They were her only link to either home or host government, which meant they had complete control over her visa, her place of work, her paycheck, and her basic rights, with the authority to decide whether to enforce those rights or silence her. They would very often entrap these women in crippling debt, confiscate their legal travel documents, and even force them to return to abusive employers. Now, while the conditions I've described might seem alien to you, it's important to remember that my case is not the only market of its kind. Transnational migrant labor has grown to 164 million worldwide, and temporary labor programs like this one have multiplied. In my own case, I'm in conversation with multiple departments from the Indonesian, Taiwanese, Hong Kong, and Filipino governments on specific policy changes and implementation. And as migration and migrant labor become more of a norm worldwide, my research will aid in the fight to develop better migration systems and support structures for other markets of its kind.
Thank you so much, Michelle, for bringing to light such an important issue in the global economy and with global migration. I want to start in the same place with you as with everybody else. It'd be great if you could tell us a little bit about what it is that made you decide to go to graduate school.
Yeah, well, when I went to undergrad at Rice University, I actually finished 2 senior theses in the span of a year, which actually helped me really understand how much I loved research. I love being able to delve really deeply into certain topics and pick them apart and figure out the best way to communicate them. So from that time, I knew I wanted to go to graduate school, mostly just because I loved research. Um, and the second part of my graduate choice to be in sociology was that I figured out that I really loved being able to use research to make an impact on the real world. My parents work in in the nonprofit sector. So I was very, very excited to find basically a perfect meshing of just my desire for research as well as using it to promote good in the world.
Thank you. What specifically drew you to this topic?
So after I graduated from undergrad, I actually worked in Hong Kong for 2 years. And during that time, I volunteered at a local shelter, a local church shelter that catered to Indonesian domestic workers specifically. I would teach them English, I would teach them, financial literacy, other things like that. And a lot of the things that I did with them was all honestly counseling and mentoring. And as they started telling me about their problems, I started noticing very distinct patterns. And it became very clear to me that these problems were not just one-offs or just individuals that had problems with each other or personality clashes. These were systemic problems, having their passports taken, having their employers being told lies by the agencies. And I kind of thought, if I want to really tackle this, I really have to get at it from a very top level perspective. I have to figure out what's causing this, because tackling it one by one is not going to do this, because again, there's 11.5 million of these people worldwide. So I wanted to find a better way to make the impact more broad.
Thank you. I'm assuming as someone that's worked with vulnerable communities, often when you're doing field work, you run into situations where you can't help people who really need help necessarily. So I'm curious, I'm guessing maybe that's part of a challenge for you, but I'm wondering what other kind of difficult challenges have you faced in doing this work?
So some of it can actually be your own mental health, which sometimes graduate school does not actually prepare you for. A lot of people in the nonprofit world will talk about, let's say, compassion fatigue. But like I said, I conducted 245 of these interviews, not including my own field work. So I would run into hundreds of these cases where these women had been placed in debt traps, or where their families were abusing them, or even in places where they were in very abusive conditions. And I would get calls late at night, as late as like midnight or 2 a.m., where their employers and their agencies are kind of teaming up to try and force them to sign an illegal contract. And I was kind of their only source of support. And it hurts. It can be very frustrating. And I had to take some time for myself when I came back from field work, which did slow down my graduation much more than I would like, but it was necessary. And honestly, I think that's a small price to pay for being able to help these women.
Thank you so much, Michelle. I think we don't talk enough about the emotional toll that qualitative research can take for many of the reasons that you're talking about, and especially when you're in communities with whom you have strong ties and strong connections. It can be, it's important to help, but it's also important you have to put the mask on you before you can take care of others. So I'm glad you were able to take the time to take care of yourself. That's our last presentation. I know I often say part of the reason I took on the role of grad dean is because our students are so incredible and amazing, and to have the opportunity to make their lives a little better is a gift. And I hope for the audience, you've seen just a taste of why I'm actually not being hyperbolic when I say that. We have just the most incredible people on our campus. And I want to thank you all for all the work that you're doing. And to reiterate the end of Michelle's talk, I hope you are all taking care of yourselves. I'm so impressed at all you're managing to do, despite the very difficult times that we're in and all the many challenges that our society is facing. I think I'm forgetting who opened up with that, but it is amazing all that you have done. So now we are turning to the part of our program where the audience gets to help us, and it is your turn to participate. So we want to ask you to vote for the People's Choice Award Just to be clear, contestants that have placed as either first or second will not be able to win the People's Choice Award. We want to be sure to spread the recognition around. And so if you go to the link that is on the slide, grad.berkeley.edu/Grad Slam, or if you scroll down in the YouTube description, you should be able to find the link there. That webpage has two places where you can go. So the first is to vote for People's Choice. Please be sure to do that. And then the second is to please send any questions that you have for our contestants. We're going to have a few minutes to be able to have them answer your questions about all the great work that they're doing. Please be sure to specify for whom you are asking a question. We want to direct it to the right person. We're going to take the questions in the order that we took the presentations. So our wonderful behind the scenes team is going to be sending me the questions in the order of people's presentations. And since we're a little bit ahead of schedule, we're going to do 2 questions for each of the contestants for them to answer so that we can learn more and benefit from their brilliance just a little bit longer. So we are now going to take a 10-minute break so that you have the time to go and vote, answer questions, take care of any biological needs you may have at this time. So we will start promptly at 4:16, if that is okay for folks. And thank you again for being here. And I look forward to hearing all of your great questions. And thanks to all the contestants for their incredible work. Welcome back, everyone. Thank you so much for taking the time to send questions for our contestants and being sure to vote for our People's Choice Award. If you recall, our first presenter was Ren Cease, and the first question we have from the audience for her is, will our galaxy become one of those galaxies that stops producing stars?
Oh, what a good question. Yeah, so right now the Milky Way is a star-forming galaxy. So it has these beautiful spiral arms like that picture that I showed. But it's kind of a wimpy star-forming galaxy. So it's much less active than many of its peers. And in some cases, people actually use the center of the Milky Way as a really local comparison to some quiescent galaxies in some circumstances. And so it's definitely on its way there. But it looks to be doing it in a very non-dramatic fashion. It's kind of just slowly declining in the rate that it's forming stars, whereas these galaxies that I was looking at kind of are shutting off with a big boom.
So now I can sound intelligent when I say that we're a wimpy galaxy.
Absolutely, yeah.
So our next question is for Rachel. How do you think scientists can better engage with other research communities working toward energy justice?
Oh, okay. That one's
not a big question at all, Rachel. Yeah, I was just kidding. It's not a big question at all. Yeah, we're going to go through, sorry, to be clear, we're going to go through all the contestants once and then go through once again. So sorry, Rachel, if you weren't ready to be the next on the hot seat. But I'll repeat, how do you think scientists can better engage with other research communities working towards energy justice?
Yeah, this is a really, really good question and something that I want to be better at as well as a scientist. So I'm not an expert in this, but I think a lot of it comes down to listening and being aware that we have a big privilege to be scientists. We've benefited from our education system for years and years, and we, as scientists, have a duty to do work that is actually beneficial to society and to really open lines of communication with folks. It's hard studying solar. Like my work, I'm just on a computer all day or I'm hiding in a lab all day, but we have to really think about, we're putting this stuff in the world. We also, we need to make sure that these technologies are really beneficial and do not further propagate harm in communities that can benefit them, and open up the dialogue, because without that, we're really solar energy cannot thrive. And so I think that's something scientists need to think about a lot more. I'm still learning.
Thank you so much, Rachel. Our next question is for Adelaide. Do we know why this system evolved to be so delicate?
Oh, that's a very interesting question. So first thing is that this system is very conserved. A lot of different species have it exactly working the same way as humans do. And it's thought that it is wired so it defends our body weight against body weight loss, instead of, going higher, which, 100 years ago or thousands of years ago was not a problem, because you would never have so much food around that you would get obese. So the real problem was to not lose too much weight. So it really defends that body weight in that sense. But then on the other side, it hasn't evolved yet to protect us from that side. So I guess that's how it's delicate in a sense, and understanding how it can break or not protect that higher limits, then will help us change the way it works for our problem that we have now, which is more obesity in our modern society.
Thank you so much. Our next question is for Iman. Will increasing vitamin B12 or folate in your diet help negate the effects of formaldehyde exposure? I think you made some folks a little nervous with your presentation.
Yeah, that's a great next step to look at. I think the thing to realize here is that the pathways in our body are very intimately connected. And that's really what our bioinformatics analysis told us. So it's not necessarily that you'll have a one-size-fits-all, fix-all solution. I think that's one of the steps that we're looking at for the future, is to see, okay, what are the pathways that are affected? How can we work towards protecting those? And also, how can we better understand how all of these pathways are intimately linked with each other? So that was kind of a big thing that we looked at in our paper, was really just understanding, okay, how is formaldehyde metabolized in our body? And what happens when you tip the scales against that endogenous or delicate metabolic balance? I hope that was a little too
Yes, no, that was
a little technical, but yes.
It was great. Thank you, Iman. Our next question is for AJ. Have you used this technique in other regions to study other cultures?
Yeah, in fact, I've tried it out in Jordan with my advisor, where we're currently working, and it hasn't worked out as well for, I think, the kind of environmental situation there. It's also a much older archaeological site. So this method isn't something I think can be applied universally. It just kind of can, it seems to work better in some places than others.
Thank you, AJ. Our next question is for Netta. Why do you use fox odor in the experiment?
Yeah, that is a great question. So we study stress, and there are a variety of stressors or commonly used stress paradigms. So, and fox urine is one of them. So if you think of stressors, there could be physiological stressors or, surgical stress. And I was going for a psychological stress or psychological stressor. And fox urine is a predator of mice, which were my animal model. So smelling the urine means that there is a predator nearby, and it provokes this life-threatening stress response that is not that has this strong psychological aspect. So it's more related to the stress that humans are perceiving, if we can make this connection.
Thank you, Netta. That was really helpful. And last but not least, Michelle, next question for you. What is an example of legislation that you have worked on to try to combat this issue?
Yeah, so a lot of that has been slowed down because of COVID and some other political situations in Asia, which not all of you are aware of, but been Hong Kong and Taiwan having problems with mainland China. But for example, some of the legislation that I've been working on has more to do with the training programs that these maids are put through before they come abroad. Most of it just has to do with recommendations of what kind of language training they're supposed to have, what kind of training they should get in terms of jobs, and also how much communication they have with their employers before they go abroad, which many of them may have only one Skype call before they actually go to meet their employers and live in their house. So yeah, and then I've also been recommending some training for employers as well, because it is not quite the same as accepting a roommate. You're also being an employer of a maid, and you have to balance being cordial with also professionality. And most employers that I've met were not prepared for that at all, and just expected the maid to adapt to whatever they wanted. And honestly, a lot of that falls on just the lack of education.
Thank you, Michelle. So now we're going to go through round two. So go through everybody, one more question for all of our amazing contestants. Ren, you're up again. Did you have internships that were really impactful for your decision to go into astronomy?
Oh, internships. Yeah, so I think the most impactful one for me was as an undergrad, I did one of these REU programs. It's a research experience for undergraduates. And I did it in Boulder at the NOAA Space Weather Prediction Center, which is actually one of the national weather centers, like the Hurricane Center, except for, things that are coming from space, namely the sun. And so I think that was a really nice opportunity to start, developing a project. I learned a ton about coding in Python, which is the language that I still code in. And just, connecting with a community of researchers and seeing a project through, start to finish was really important.
Thanks, Ren, and to all the undergraduates, if there are any in the audience, remembering the importance of signing yourself up for those kinds of opportunities to find your path is important. Next question is for Rachel. What percentage increase in efficiency do you expect with these materials?
Yeah, no, that's a great question. And this really depends on solar technology. So the actual efficiency is set by that absorber layer that I was talking about in my talk. So that gives like the maximum efficiency of a particular technology. Maybe you've heard of silicon. So that's given by the limits given by silicon. But I like to think of contacts as a way to fill the gap. So basically like good contacts are like a straw that can slurp all the bits out of the bottom of a drink, like of a glass of orange juice or something. So you can make sure to get all the charge out that is not getting out. As of now, there's a big gap between maximum theoretical efficiency and actual efficiency like in the lab. And then what's really important to think about too is what happens when you leave solar panels out for a long period of time. They're going to degrade, and a lot of that degradation happens in the contact. So some of the answers we don't even know. We need to make sure that we're testing for long-term panels that are not just going to contribute more to the weight cycle. And so contacts are really important in that pursuit as well.
Thank you very much, Rachel. Next is Adelaide. How far away, time-wise, would you say your work is from being turned into medicines for people?
Oh, wow. I can't really give a timeline, but there are some new agonists that are being developed right now that are working for MC4R and for that system. And we don't understand how they work, but MC4R being at the primary cilium might give us some answers. So I really can't wait to test those new agonists and those new drugs in my system to see how they influence this new system that we put in light. And but there are so many secondary effects that also can happen by activating that system that I really don't know when they will be able to be put outside in the world. So I don't know when, but hopefully soon.
Thank you very much, Adelaide. You can see that our audience is not a bunch of slackers. The folks have asked some really great questions. So thanks all for handling them so deftly. Iman, the next one is for you. What is one of the most common sources of formaldehyde exposure?
Oh, that's a great question. So the most common way that formaldehyde is used that folks would be exposed to is as a resin in pressed wood products. So if you're familiar with laminate flooring, that can typically off-gas a lot of formaldehyde, especially in warmer months. If you're talking about places where you have especially high exposures, that typically happens in anatomy labs, where the cadavers are soaked in formalin or formaldehyde solution. You can also have embalmers, similarly in funeral homes where the body is embalmed using the formaldehyde solution. And then the other occupational sources include like textile workers and things like that. But as far as folks in their home go, it's typically in the wood products, furniture, and places like that.
Thank you. And do you want to tell folks what's the certification that you would need to see in order to know it won't off-gas in that way? Like an engineered wood product, when you're buying it, are there ways to know that it's not a source of formaldehyde?
That's a great question. So we actually have exposure limits that are set, that are pre-established by government agencies. So products that you're sold with that contain formaldehyde would not be able to exceed a certain amount. In California, we have the Prop 65 warning. So every product that you might be sold with formaldehyde in it has to come with that label that warns you that, you know, it's a chemical that's known to the state of California to cause cancer. But I think the reason that this is such a good question is because sometimes you have products that are imported into the country that exceed those exposure levels, which is why even though we should be protected from high exposures to the chemical, you can have instances where, you know, folks may ignore the regulation, sell a bunch of product, and potentially expose a lot of folks to very high levels of the chemical.
Thank you. Sorry, I gave her an extra question, but I figured folks might want to know how to avoid it since we live with this every day.
That's a great question. You won't typically have an exposure monitor though. If that was like, it's not like you can, I mean, you can, there are some formaldehyde monitors, but that's typically not something that you would buy and stick in your home, similar to a carbon monoxide monitor or a fire alarm or something like that.
Thank you. AJ, you're up next. Could you expand on oral histories and how that ties into your research?
Yeah, just let me collect myself after a second because I'm staring at this like wooden table, kind of freaked out. So there is a long sort of tradition of Native peoples basically knowing that there were people after Cahokia, basically. And that is a form of evidence that I think is often underappreciated by, you know, kind of quote unquote science sometimes. But what we find is that there are many instances where oral histories and, you know, archaeological findings parallel or coincide very well. And I'd say that's what we have at Cahokia, which is to say that, yeah, it's not like there's this, you know, belief that this is this completely vacant area. We know that there are stories of people living there and historical references as well of Europeans interacting with indigenous peoples well after the traditional occupation of Cahokia.
Thank you, AJ. Our next question is for Neta. Is life-threatening stress a good comparison to what a human mother experiences?
Is the life-threatening stress a good comparison? I think that what a pregnant mother experiences is very individual. So there's no, you know, one experience for all. The life-threatening experience comes from wanting to study how stress affects pregnancy and pregnancy outcomes. Some mothers are more or less vulnerable or susceptible to stress, and you know, individual experience different stressors throughout their pregnancy, but also cope and process stress differently. So some may experience life-threatening stress and others may not. But there are definitely some individuals and some populations that are more at higher risk to these negative pregnancy outcomes and at higher stress. Either it's because, you know, the social economic status, or people of color, or some medical reasons for being at higher risks. So life-threatening for some, less for others.
Thank you, Neta. And our last question is for Michelle, last but not least. So I'm going to tweak it a little. The audience member asked how many in-person interviews you conducted, but I think you said 245, if I'm remembering correctly. So maybe I'll tweak it and say, why did you think it was important to talk to that many people in order to do your work?
Yeah, well, a part of that has to do with that I'm studying 4 different countries. So, you know, I had to get a good sample from all 4 of them. And I was also studying 5 different subpopulations. It's the maids themselves, of course, their employers, the government, the agencies, and the activists. And again, I wanted a good sample from all of those from across all 4 countries. So that was just do the math. That adds up very fast. But the reason I chose to do in-depth interviews is because this market is extremely opaque. It does not lend itself well to practically any other form of research, even surveys. A lot of the domestic workers, when they receive a survey, will often think that they are being tracked by the government or by their agency. And if they answer wrong, they'll be sent home with a massive debt. So trying to give them just like the normal survey we would give to Americans was just not culturally appropriate. It also really helped when they heard me speaking Indonesian or Mandarin. They realized that I had taken the extra step to try and learn what their life was like. And that allowed them to open up and actually share what they were really feeling rather than try and hide it behind like a lot of what was the appropriate answer, the way they're supposed to answer. It took a lot of time. And I have to say, it wasn't just the interviews that allowed that, it was the participant observation, just actually being able to spend hours and hours with them and not expecting anything in return, though asking for it. And also having to convince these women that, yes, your story is worth telling.
Thank you so much, Michelle. And thank you again to all of you. Thank you to our audience members for asking such really great questions. And thanks to all of you for doing such a great job of fielding them on the fly. I know that that can be difficult and you all did a wonderful job. So now is the moment everyone's been waiting for. I wish I had some sort of virtual drum roll to do for you. We will proceed with the presentation of the awards. The first award is for People's Choice. And I'm realizing I don't have it yet. Do we have any, music to play? Somebody, anybody? We're all about generosity and grace in the virtual world with one another. Oh, a trombone, I like that. We could have a whole, I should have had my kids play music. So I'm gonna ask the powers that be. Ah, fabulous, so drum roll please, everybody. People's Choice Award. I'm getting it now. Iman Rana, yay! Congratulations. So you are our People's Choice Award. I don't know if you want to say a couple words, and then we'll go on to the next.
This is a huge honor, and I'm really, really thrilled that I was able to share my research with all of you. So thank you, huge thank you to my mentors, my collaborators, my family. This is a huge honor.
Thank you so much, Iman. So now we're going on to second place winner. Trombone, drum roll, imagine whatever musical instrument in your head you want to hear. Our second place winner is Netta Gottlieb from the psychology department studying behavioral and systems neuroscience for her project entitled The Impact of Stress on Pregnancy. Congratulations.
Wow, thank you. This is truly an honor. And thank you and thank you for the committee and my amazing collaborators and research assistants and my advisor, Lance Kriegsfeld. And thank you all for being here.
Thank you so much, Netta. And then finally, I'm looking for my right, here we go. Our champion and the person that will be representing Berkeley in the system-wide competition. Can we have some drum roll? Champion is Adelaide Bernard from Metabolic Biology for her project entitled Hungry Unicorns, How Antennas in Your Neurons Control Appetite. And can I tell you that my 15-year-old daughter was thrilled that something with unicorns in the title could be part of research at Berkeley. So you've done double duty for me today. Congratulations, Adelaide.
Oh, thank you so much. I really can't believe it. I'm so grateful, to everyone who gave me feedback on my presentation, and this has been really an amazing adventure. So, oh my God, I can't believe it. Thank you. Thank you so much.
Sorry. As we wrap up, you know that has to happen once in every Zoom meeting, talking with mute. Please join me in giving just a big round of applause to all of our contestants, Zoom applause, however you want to do it, who just did such an amazing job sharing their research with us today. I'd also like to thank our judges, our keynote speaker, who was inspiring and amazing, the advisory committee for graduate student and postdoctoral scholar professional development, and the staff members in the graduate division and ETS who made all of this possible. And as you can imagine, it's this virtual format is a challenge. I in particular want to thank Linda Van Hunne, Kathleen Aycock, Larissa Chansangave, Ali Gleason, and Gwendol Ponteux who all just worked so hard to make this event as tight and organized as it can be. And I want to thank you all for being with us today and for all you do to support graduate education at Berkeley. I hope you enjoy the rest of your day. Congratulations to all of our finalists. You are all winners. And Berkeley's gonna win the system-wide this year, I'm sure. Not to be competitive, but go Bears, and best of luck and best wishes for the rest of your day. Thank you, everybody.